Imagine placing your entire company inside one massive open warehouse. You have the human resources department conducting interviews, the finance team reviewing payroll, and the guest Wi-Fi users streaming videos, all in the same room at the exact same time. The noise becomes deafening, and keeping sensitive conversations private is impossible. This diagram shows what that warehouse looks like inside a physical network switch. In networking terms, this single open space is called a single broadcast domain. Because every device shares the same network space, a message sent by one computer floods out to every other computer. The result is constant traffic jams that slow everything down and leave your secure data completely exposed. A beginner might look at this chaos and think the only solution is to buy separate physical switches for every single department. But hardware gets expensive quickly. A senior network engineer fixes the architecture itself. Watch how we partition this single box. We use code to construct virtual, soundproof walls directly inside the switch. These isolated rooms are called VLANs, which stands for Virtual Local Area Networks. The physical switch remains exactly the same, but logically, the departments are now completely isolated. These virtual walls turn a standard switch into an intelligent traffic controller, ensuring that a simple guest login never creates a company-wide bottleneck. Before configuring a switch, you have to map the network to the actual business. Creating boundaries randomly creates a mess. You need a purposeful blueprint. Look at this floor plan. We isolate systems based on their function and sensitivity. Our servers hold critical company data, so they get their own dedicated room. Guest devices are kept entirely separate. And one strict rule we follow here: we never use the default network, known as VLAN 1, because attackers often target it first. To get a device into one of these secure rooms, we use an access port. Think of an access port as a locked door that leads to one and only one specific room. See this printer connecting to the switch? It is strictly assigned to the HR VLAN. Even though it is physically plugged into the exact same switch as the guest Wi-Fi router, a guest device cannot see or print to the HR printer. The virtual walls block it. Engineers lock these doors using simple text commands. Telling the switch to put a port in access mode officially secures that connection to a single VLAN. By placing every computer, phone, and camera into its correct virtual room, we eliminate the chaotic crosstalk that crashes poorly designed networks. This isolation works beautifully on one switch, but enterprise networks span multiple floors and buildings. How do we keep these virtual rooms intact when traffic has to travel across the building to another switch? We use a trunk port. If an access port is a door to a single room, a trunk port is a high-speed elevator. It carries the traffic for all the different VLANs simultaneously between switches. As data enters this trunk pipe, the switch has to keep everything organized. It uses a standard called 802.1q to attach a VIP license plate to every piece of data. This digital tag tells the receiving switch exactly which virtual room the data belongs in, ensuring HR data never accidentally spills into the finance room. Because trunk ports touch multiple networks, they are prime targets for attacks, so we explicitly tell the trunk elevator to reject any traffic that doesn't have an approved tag. This creates perfect isolation, but it also creates a new problem. If the walls are truly soundproof, how does the HR manager send an email to the finance director? We have to install a secure intercom system between the rooms. In networking, this is called Inter-VLAN routing. This router acts like a specialized gatekeeper. While a basic switch only understands how to move data along local wires, a router is a Layer 3 device, smart enough to read network addresses and carefully guide messages across the virtual borders we've built. Trunk ports allow your network to grow to any size, and inter-VLAN routing allows your departments to communicate on your exact terms. A brilliant architectural blueprint is useless if the front door is left wide open. Unused wall jacks and empty switch ports are severe vulnerabilities. An attacker can easily plug a laptop into a forgotten lobby port. To prevent this, every unused port must be manually shut down and assigned to a dead-end network. When an issue does happen, guessing wastes time. This terminal readout shows a verification command. It cleanly lists every VLAN and the exact ports assigned to them, giving us instant visibility into the architecture we built.
Beginners rely on typing configurations blindly and hoping the system works.
Senior professionals document everything, map their ports, and verify their connections before declaring the job done. Look at the difference between the chaotic, flat network we started with and the optimized architecture we built using VLANs. We secured the data, contained the broadcast noise, and created a stable environment. Ultimately, a network's reliability doesn't come from the physical cables or the price of the hardware. It comes from the logic used to organize it. Using VLANs allows you to build a stable environment that can support thousands of users while keeping every department secure.